What if I told you that the fate of nations, economies, and the environment hinges on a single factor: how we make decisions? From war rooms to climate negotiations, the way leaders analyze information and allocate finite resources determines our future. But in an increasingly complex world, how do we ensure that those decisions are the right ones? Enter decision analytics and systems modeling, or more simply, decision modeling.
Decision modeling is a process-oriented approach that represents the flow of information and interactions within systems, integrating machine learning, optimization, probability, and statistics with advanced mathematical models to support decision-making in complex and uncertain environments.
These systems are built upon a foundation of advanced computing infrastructure, powerful semiconductors, and sophisticated algorithms that enable the processing of vast datasets at unprecedented speeds. The Cold War was a game of high-stakes decision-making. One wrong move could mean global catastrophe. In the early 1980s, the movie War Games dramatized this fear: a supercomputer learning that nuclear war has no winner. But this wasn't just fiction. The Reagan administration took it seriously, leading to real discussions on decision support systems for nuclear strategy. The need for more sophisticated decision-making tools became clear. At the same time, scientists were developing models to predict resource scarcity, economic collapses, and climate change. The Club of Rome's 1972 Limits to Growth report was among the early uses of computer modeling to simulate future global scenarios. These early forms of decision modeling paved the way for today's advanced decision analytics. Universities played a crucial role in developing decision modeling. Herbert Simon's work at Carnegie Mellon on bounded rationality, the idea that our decision-making is limited by time, cognition, and information, helped lay the foundation for modern analytics. Academic institutions continue to be at the forefront of refining these models, ensuring they remain adaptable to society's evolving needs. The exponential growth in computing power predicted by Moore's Law, alongside advancements in data storage, artificial intelligence, and semiconductor fabrication, transformed these mathematical concepts into powerful tools. Each generation of chips enabled more complex models and algorithms, allowing us to tackle increasingly difficult decision problems.
Fast forward to today, and decision modeling is embedded in how governments manage finite resources, whether it's optimizing energy grids, predicting climate disasters, or allocating pandemic relief funds. These models process vast amounts of data to guide policymakers to the best possible choices. These applications are only possible because of breakthroughs in machine learning algorithms and artificial intelligence systems that can identify patterns in enormous data sets that would be impossible for humans to detect. The biggest advantage? Speed and accuracy. Human decision-making is limited by time, bias, and incomplete information. Decision modeling enhances our ability to analyze variables, simulate outcomes, and make evidence-based decisions at a scale that no human brain can match.
But what happens when these systems get it wrong? Algorithms can reinforce biases, bad data can mislead policymakers, and over-reliance on automation can erode human intuition. There's also the question of transparency. Who controls these models, and can we trust their outputs?
There's also an issue of equity. While high-income nations and corporations have access to cutting-edge analytics, marginalized communities often lack representation in these models, leading to decisions that may reinforce existing inequalities. Addressing these gaps is crucial for ethical development. Hollywood has long speculated on the power and perils of decision-making machines. From HAL 9000 to predictive policing in Minority Report, these stories explore what happens when technology makes decisions for us. The reality is more nuanced, but these narratives shape public perception and policy responses to emerging tech. Decision modeling has changed how governments and industries function. It helps cities allocate resources, businesses optimize supply chains, and even influences elections through predictive analytics. This transformation raises ethical and governance challenges that we must navigate carefully. Governments, universities, and industry leaders are grappling with how to regulate decision modeling. Organizations like the National Science Foundation, the United Nations, and tech companies are shaping policies to ensure these models are ethical and accountable. However, policies must evolve to keep pace with technological advancements. Transparency mandates, ethical AI governance, and policies addressing biases in data models will be crucial to ensuring decision modeling benefits all of society. Decision modeling involves multiple stakeholders: government agencies, academic institutions, private tech companies, and nonprofits. Each plays a role in developing, regulating, and applying these technologies to real-world problems. Ensuring collaboration among these entities is crucial for ethical and effective implementation. This occurs in places like the Decision Theater at Arizona State University.
Right now, researchers from Arizona State University are working to model the weather of the entire planetary system and incorporate differential social dynamics inspired by studies on the future. Future breakthroughs will be driven by innovations in semiconductor technology, quantum computing, and neuromorphic chips that mimic brain function, potentially unlocking entirely new classes of decision models that we can barely conceive of today.
The future of decision modeling will be shaped by how we address its shortcomings today. Will it be a tool for greater equity and sustainability, or will it deepen existing divides? The choices we make now will define its role in shaping the world.
At its core, decision modeling is a tool, not a solution. The real challenge lies in how we use it. Will we let machines make the hard choices, or will we use them to enhance human wisdom? The future of decision-making lies in our hands. How do you think we should use this technology?